Good evening all. Welcome to ACE Engineering Academy and ACE online platform. So let us discuss today about questions that were given in ISRO paper electrical engineering branch. First let us see the weightage. So this is the weightage in each subject given. Electrical mission 19 questions came. So this takes the highest number of questions. Power system 6, power electronics 10, measurements and instrumentation 9, electrical circuits or network theory 11 questions came, control systems 8, electromagnetic theory 5, analog and digital electronics 4, signals and systems only 2 questions, mathematics 7, and aptitude are 14. So clubbed together it is 95 questions. All topics that were given in your syllabus are covered. There is nothing that question did not cover from any part. All the things came. So let us first go through the network theory part or electrical circuit part that is given in today's paper. So let us discuss these questions first. And the remaining part will be covered by other faculties. So this is the first question. What is the value of the current I in the following picture? So this question, if you observe carefully, you are having there is no simplification that is there here. First hand simplification. There is a current source and there is a voltage source. So better go through or apply the superposition principle. So if you apply this superposition principle or superposition theorem, you can go with one source at a time. So if I am opting only with the 6 amps current source, if you short circuit the voltage source, this 3 and this resistance will come in parallel, and again 2 and 1 also will come in parallel. And the equivalent that you have here is this part of the circuit. So when the voltage source is short circuited, this is what you will have. So this 2 and 1 will be in parallel, so it becomes 2 by 3 ohms. And this 3 and 3 will come in parallel, so it will become 1.5 ohms. And then you are having 2 ohms here. And across this there is a current source of 6 amps. So this is your final simplified circuit when you are keeping only current source. And what is our response? Response, we have to find the current across 2 ohms resistor. So this I am marking it as I1. So across this branch, this 1.5 and 2 by 3 are in parallel. So if you take, these two are in series and the combination will come in parallel. So if you take this, this is like a 3 by 2 added with a 2 by 3. So if you take, this becomes 9 plus 4 divided by 6. So it will be 13 by 6 ohms. So if you directly apply current division principle, what is the value of I1 you will get? 2 ohms and this 13 by 6 will come in parallel with each other. So that means current flowing on 2 ohms will be this 13 by 6 divided by 2 plus 13 by 6 multiplied by the total current, which is 6 amps. So you can express this as 13 divided by 25, 12 plus 13 into 6. So this will be the total current that would be flowing on 2 ohms resistor only because of the current source. Now similarly, if you apply only with the voltage source, that means 6 amps current source, you make an open circuit and do, then the answer you will be getting will be this 96 by 25 amps. So that part you can try. You can keep the voltage source, write a nodal equation remaining the current, removing the current source, then you will get that part. So that is how you can try out this question. Let's see the next one. The current voltage characteristic of a particular component is given. He is asking what is the property. So this is not a straight line passing through origin. So when the curve is not a straight line passing through origin, then network element happens to be non-linear. And you can see here the ratio of voltage to current is positive in this coordinate. Here it will become negative. That means network element is active. Power is negative means network element should be active. And the symmetricity is also not there because first and third are symmetrical, second and fourth will be symmetrical. So when the curves are not same, the element becomes unilateral. So the given network element is non-linear, active and unilateral element. So the correct choice for this would be option B. Okay, simple question, theory bit. Coming to the next question. So here he has given circuit diagram. Here the data, I think this should be not microseconds, it should be in milliseconds. A little bit change has to be there. Just understand that point. He is asking what could be the maximum possible voltage that can be coming on the capacitive branch. So basically this is an RC circuit. Okay. So what is the time constant? it will be R equivalent into C. So when you see the R equivalent from the capacitive terminal, these two will come in parallel. So it becomes a 10 by 11 kilo ohms, and C equivalent is 11 micro. So this value comes out to be 10 milliseconds. Okay. So what is the expression for voltage on capacitive branch? It will be final value plus initial value minus final value into e power minus t by this time constant, which is your R equivalent into C equivalent. So final value of voltage that maximum can come is voltage division principle, 10K divided by 11K into your 11 volts voltage. So automatically it becomes 10 volts. Initially there is no voltage, 0 minus 10 into this e power minus t by 10 in milli. So in numerator you can write it as 10 cube. So you can express this Vc of t as 10 into 1 minus e power minus 100 t. Okay. Now because you are applying your pulse for 10 milliseconds, so the maximum possible value of voltage that you can get is 10 into 1 minus e power minus 1. So this comes out to be around 6.32 volts. So this should be your correct choice. So if this is micro, then you cannot get any answer. So possibly it is the pulse which you are applying for 10 milliseconds. Okay. Next, what is the Norton resistance across the terminals A and B for figure shown in the figure? This here you can see this is a dependent source and this is independent source. So when you have both the sources acting in the network, when only you want to calculate R equivalent, you can open circuit this branch. You can remove independent source. So current source, when you remove, it becomes open circuit. So the remaining part of the circuit we have will be this 6 ohms resistance on which current is I naught, and this dependent source 9 I naught and 2 ohms resistor. Now across the branch on which you are asked to calculate R equivalent, you connect an ideal voltage source V that delivers current I into the network. It should be always into the network. So these are your reference terminals A and B. So looking into these terminals, calculate R equivalent. That will be ratio of V to I. That's all. So obviously the current flowing in the network is I, and I and I naught are same. Both are in the same reference direction. So you can write V minus 2 into I naught plus 9 into I naught minus 6 into I naught equal to 0. So you will get V equal to minus I naught. So your R equivalent or R Thevenin is this ratio of V to I naught. So in your options they have given negative values also. Generally resistance as in network theory concerned it should be positive, but because he has given with that value, go with minus 1 ohm only. Okay. So standard procedure, nothing very difficult in this question. Next, an ideal voltage source is connected in parallel with an ideal current source. So what is the meaning? Ideal voltage source means the internal resistance is 0. It should be connected in series, so 0 resistance. Ideal current source means internal resistance is infinite, which should be connected in parallel. So you can represent an open circuit branch. Now across your reference terminals A and B, if you see the network has only Thevenin voltage, which we can write as Vs, and Thevenin resistance, short circuit voltage source, open circuit current source, 0. So what we can draw? The Thevenin equivalent circuit we can represent with a voltage source of Vs. There is no resistance that will be connected in series. So this is how you can draw only Thevenin equivalent. Norton current we cannot find, because when the Thevenin resistance becomes 0, Norton current becomes infinite, which is practically not possible to implement. So only possible choice here is only Thevenin equivalent. It's a standard gate bit also. It came many times in other competitive exams. Next, similar question. Which of the following combinations of open circuit voltage and Thevenin equivalent resistance represent the circuit? Means he is actually asking you to find the Thevenin equivalent across the terminals A and B. So the same voltage will come here. You can write this as VTH. So what is the nodal equation we can write at this point? minus I1 current coming towards the node, minus 99 I1 current coming towards the node. There is no current on right circuit, it's an open circuit branch, equal to 0. So I1 becomes 0. So if you take this I1, what is I1? As per the representation, it is 1 minus VTH by 1K. Now because I1 becomes 0, the value of VTH will be automatically 1 volt. So your possible options should be either A or B. You can eliminate C and D. Now, what is this RTH? You are having both independent as well as a dependent source. You can go with the standard procedure. You can short circuit this branch and connect an ideal voltage source which delivers current I with voltage V. If you take the ratios of V to I, the value you will get will be A. So R equivalent or RTH seen from these terminals will be 10 ohms. Standard questions, I think Thevenin they gave a lot of importance. 2-3 questions on the same topic came. Next, for the circuit shown in the figure, the value of voltage V0. So here, if you apply concept of source transformation, 4 volts is in series with 2 ohms. So I can convert that into a current source. 4 by 2 will be 2 amps, arrow upward, and 2 ohms resistance will come in parallel. So he did not talk about this diode, what is kept here, whether it is ideal or practical diode, we don't know. Just keep it in the same place. V0 is reference given, minus and plus. So node voltage, you can write it as minus V0, assuming diode is forward biased. And this is 2 ohms, or you can take source transformation here also. I can remove this branch. 2 ohms resistance will come in parallel, and arrow downward, this will be 1 amps. So if you go with the normal nodal equation for finding the value of V0, he is asking V0 only, assuming the diode is forward biased, then now none of these values will match. So only possible choice is none of the above. Just concept based on source transformation. But diode, he did not talk anything. So by seeing these voltages and currents that are coming towards the node, you can assume as a ideal diode which is becoming forward biased. So you can replace by a short circuit and proceed further. Okay. Next, the phasor current through the inductance in the given circuit is dash. So here you can see this is a current source. This impedance will be SL, so it becomes S. So what is the response he is asking? Current across inductive branch means IL of S. So let us assume this current source is I of S. So if you go with the standard transfer function model, output I require is current across inductive branch, input I am giving is current source. So what is this IL of S? Current division principle. Opposite branch resistance is 2 divided by total 2 plus S multiplied by current I of S. Current division logic. So your H of S as per this will be directly 2 by S plus 2. Now if you are replacing S with j omega, given value of the source frequency is 2, so this becomes 2 by j2 plus 2. You can write it as 1 by 1 plus j, or magnitude will be 1 by root 2, phase will be minus 45 degrees. So what is the steady state current flowing across the inductive branch? What we do, we take the input signal amplitude which is 10, multiply with amplitude response. Because circuits are linear, excitation does not change. So the frequency will remain same. Phases will get added, input phase is 0, phase response we got is minus 45 degrees. Multiply amplitude, add phase. So you will get 10 by root 2 cos 2t minus 45 degrees. So straightforward that answer will be this. Directly given question, use a transfer function model. Right? Next, the dependent source in the circuit shown below here is a direct model, current control, current source. Straight away by seeing you can tell that. A theory bit. If the voltage across a 5 farad capacitor, so capacitance value is given, voltage across capacitor, Vc of t is 2t e power minus 3t volts. current through the capacitor. So relation is C into d by dt of voltage across capacitor. So substitute that values and take a derivative. So 5 into 2 you can write outside. This is a t into e power minus 3t, derivative will be minus 3 e power minus 3t plus e power minus 3 derivative of t will be 1. So this IC of t will be 10 into e power minus 3t minus 30t e power minus 3t in amps for values of t greater than 0. So possible choice is option D. Simple question, just using the relation between voltage and current across a capacitive branch. So these are all the questions given on a network theory paper. Pretty straightforward questions and formula related things only. Okay, hope all the points are clear. My colleague will take the next